Space just inspires everyone of different backgrounds, different nationalities. So I think it gives, in a sense, kind of hope for humanity. I'm Julie Lee, and my job is to propel the Psyche spacecraft to a metal-rich asteroid. So this is the Psyche spacecraft. We're basically looking at a spaceship that's going into space. It's going to explore a metal world that is the Psyche asteroid, and it could be the remnants of the beginning of a planet. My role is to basically oversee the development of the electric propulsion hardware. The DSNs that you see on the spacecraft with the red covers are essentially deployable stationary plasma thrusters. They're very small, but it's able to carry all of the scientific instruments and a significant amount of science payload to the asteroid. And as you can see, this little fixture right here that is deployed out is our deployable stationary plasma thrusters. I knew I wanted to pursue aerospace engineering because I wanted to be an astronaut. Growing up in the 90s, I think that was the peak of all the space shuttle missions. So I remember just watching all the space shuttle launches with my parents. But my first job out of college was a design engineer for the space shuttle mission. Everyone is fascinated by the unknown. It's extremely difficult science and technology, but it's possible. By nature, I just like to challenge myself. I'm very interested in daring exploration. I've been skydiving, I've been cage shark diving. I also summited Mount Kilimanjaro, and hopefully someday, maybe I'll get to explore space myself.
Hi everyone, I'm Emily Richardson from NASA's Jet Propulsion Laboratory in Southern California. In just a moment, I'll be joined by Julie Lee to answer your questions about Psyche, a first-of-its-kind mission that after it launches next month will travel beyond Mars to explore an asteroid made not just of rock and ice, but of significant amounts of metal. To get there, it will use a super-efficient solar electric propulsion system. Today's guest is very familiar with this system, having overseen its development at Maxar Technologies. And now she's joining us live to answer your questions. Thanks for joining us today, Julie.
Hi, Emily. I'm extremely excited to join you and our viewers to have a discussion today that is truly out of this world.
I love that. And to everyone watching online, remember, Julie's here to answer your questions. So drop them in the chat of whatever stream you're watching or send it in using the hashtag AskNASA. But first, Julie, we're less than a month until the launch. Tell us a little bit about the Psyche mission and the spacecraft that you've helped build.
Well, from existing radar data, scientists believe that Psyche is composed of mostly metal. The core of most planets are also made of metal, so this suggests that Psyche is possibly the remnants of the beginnings of a planetary formation that was destroyed by collisions. And to confirm this study, scientists will perform a mission with some key instruments that will map out the topography and the elemental composition of Psyche. To carry these instruments to Psyche, we are using Maxar's heritage electric propulsion system that will carry these instruments through the 6+ years till we reach Psyche for that study.
Yeah, and watching that intro video, I have to say, this propulsion system sounds almost sci-fi worthy. Can you tell us how Psyche's massive solar panels, xenon propellant, and plasma thrusters will work together to transport the spacecraft 2.2 billion miles through space?
Well, Psyche will utilize Maxar's Heritage 1300 spacecraft platform, which is the most reliable spacecraft design in the industry. And Maxar is also leading the industry in solar electric propulsion. We have flown many spacecrafts with this specific electric propulsion space subsystem before for decades, and we're extremely excited to elevate it to its application of this deep space mission that will fly beyond the moon to an asteroid for the very first time for this mission. The stars of the electric propulsion system are our dual-axis deployable stationary plasma thrusters, and these are a class of Hall effect thrusters. These thrusters will actually deploy out in space. The easiest way to explain it is imagine Iron Man, and when he stretches out his arms and pushes up, that's essentially what these deployable stationary plasma thrusters will do. After the solar rays are deployed, we will utilize that electricity to create an electromagnetic field, which will ionize the propellant, in this case, which was xenon, this essentially will accelerate the ions, creating the thrust. So we use xenon because it is the heaviest atomic molecule, which means that it generates the most thrust. And we currently hold a world record for loading the most xenon on a spacecraft in the world. And this propellant is managed by our feed system, which is composed of numerous regulators and valves, which control the flow of xenon to these thrusters, providing just the right amount of thrust for this mission.
Wow. So it's not science fiction. It's very much science reality and engineering reality done by very incredibly smart people like you. One more question from me before we get to our viewers. It looks like you're joining us today from a really cool location. Can you tell us about where you're joining us from?
Yes, I am joining today from Maxar Technologies in Palo Alto. And behind me, you can see one of our massive high bays. And in direct view is our solar array rig, which deploys and tests all of our solar arrays. And the Psyche spacecraft was built and tested through this high bay just about 2 years ago. And we are one of the leading companies in the country and in the world, actually, for spacecrafts for not only government, but also commercial as well as NASA missions. And we are also currently supporting 3 NASA missions with the same spacecraft platform that is on Psyche. These are the missions of TEMPO, OSAM, and the power propulsion element for the Artemis Gateway program. And so for the power and propulsion element, we will actually be elevating Psyche's electric propulsion subsystem, but tripling the power for that mission to the moon.
Wow. That's so incredible. And, partnerships are so important to the work that we do. Questions are really rolling in here, so let's get to some of them. As a reminder, if you have a question for Julie, you can send it in using the hashtag #AskNASA or by dropping it in the chat wherever you're watching the stream today. But let's just dive in here. First up, Future Astronauts on YouTube asks, what inspired you to join NASA?
Well, I've always had the dream ever since I was little to be an astronaut. So the easiest pathway in my mind was to become an aerospace engineer, work in the industry, work on as many spacecrafts and launch vehicles and collaborations with all fields of the space industry as possible to hopefully get my foot in the door. And so Maxar was a great place for that. It's an extremely a great place to learn very quickly. We have the highest cadence of spacecraft design and production, and we constantly have about a dozen spacecrafts and missions going through our facility in a single year. So that was my inspiration.
Mm-hmm. Next up, Mark on YouTube asks, how was Psyche discovered in the first place?
Dr. Lindy, our principal investigator, might be able to answer this better. But from what I know, there's existing data from radar observations and thermal inertia that suggests that Psyche is composed of mostly metal, which has been unseen in other asteroids, which are mostly rock and ice. So that is how this discovery came to be.
Very cool. And yes, there's tons of information about that on the Psyche website, nasa.gov/Psyche. There's, I'm sure, really great information to dive into that some more. The next question, I think, is a great fit for you. Totaling Arc on YouTube asks, was the propulsion system originally calculated to be faster, making the trip shorter?
So we are utilizing this propulsion subsystem not particularly because it's faster, but because it is more efficient. So meaning it will allow us to go the 2.2 billion miles with minimal amount of propulsion mass. So electric propulsion is typically more efficient than chemical propulsion. So that means it has better specific impulse and that it can provide the more accurate low thrust levels that are possible, but operate through a much longer mission life.
Yeah, I was reading some of the materials online, and I saw something that said the mission will get an equivalent of nearly 10 million miles to the gallon, which is pretty efficient.
Yes, definitely.
All right. Drew on Facebook asks, what has been your favorite part of the mission, and what do you hope that we can gain from the launch, and I guess from arriving at the asteroid and studying it?
Well, my favorite part of the mission has been collaborating with a great institution like JPL and learning from the other teams and other disciplines. For me, being in this industry, the best part is just the opportunity to never stop learning, not from only my internal Maxar team, but from other great institutions like JPL. And the most exciting part about the study, I would say, is that we'll have a better understanding of the formation of planets and our galaxies and a better understanding of our Earth, and hopefully more appreciation for the planet that we live on.
And thanks to everyone for sending in these really great questions. Keep sending them in for us. We have some more time with Julie here, and we want to get through as many as possible. We're so excited, looking forward to this October 5th launch of Psyche. Now, Julie, Maurice on YouTube asks, is there any chance of collecting xenon in space for refueling?
Unfortunately, that might be a little difficult. I'm not sure if that technology quite exists yet, although I'm sure there are many smart scientists out there who are working on that. The difficulty with collecting xenon in space is that we're in a vacuum, so xenon will pretty much disperse into that vacuum of the deep hole that is space, unlike Earth, where there's gravity and there's atmosphere and we are better able to capture it. So I don't believe that technology exists yet, but anything is possible.
So earlier we were talking about the trajectory. So it's not just a straight path to Psyche, correct? It's going to be doing some gravity assists on the way. Can you talk a little bit more about that?
Right. So the spacecraft will first, after launch, it will be in an orbit on the way to Mars so that we can use Mars's gravity assist. And the Mars's gravity assist will actually introduce somewhat of a slingshot-like trajectory for Psyche. So we'll save some propellant in that sense. After the Mars gravity assist, we'll continue onto a couple more orbits until we reach the spacecraft, until we reach the asteroid itself. Once we reach the asteroid, the studies will be performed on 3 or 4 different orbits. And ultimately, the final orbit is about 75 kilometers above the surface of the asteroid.
And that's an important point too, right? We're not landing on Psyche, we're orbiting it and using the science instruments to study and learn.
Yep, correct.
Nice. Okay, so Dylan on YouTube asks, you touched on this earlier, but can you talk a little bit more about what type of electric propulsion is Psyche? It asks, are ArcJet, Hall, Ionic?
So yes. So Psyche is a Hall effect thruster. So again, it uses an electromagnetic field to ionize the xenon, in which the ions from xenon will be accelerated, and that produces the thrust that we use for this mission.
Right. And I believe you've also talked about how there's something about a AA battery, right? The approximate thrust that the weight of a battery would put on your hand.
Yep. So the thrust of these thrusters are only on the order of magnitude of a couple hundred millinewtons. Even though this is an extremely small amount of thrust, we are in space, which means that it is vacuum. There's no atmosphere. There are no opposing forces. So a tiny bit of force will allow us to move through space. And we need that low thrust to be able to control our very precise trajectory.
Yeah, I love just thinking about the system working together, these huge solar arrays that are 37 feet long and 24 feet wide, enormous solar arrays that are powering this super efficient propulsion system. Really is so sci-fi. All right, we have another great question from Maurice on YouTube who asks, will we eventually run out of xenon when more and more spacecraft use electric propulsion? Some have already switched to other noble gases.
Right. So xenon is farmed from the atmosphere. I don't believe I think there would be an extensive demand for xenon usage for us to run out of xenon in the atmosphere. But there are other noble gases that can currently be used for electric propulsion, specifically krypton and argon. But these gases are less heavy in mass than xenon, so they're slightly less efficient and don't give you the same amount of thrust. But in the industry, these gases are a little more easy to procure than xenon, so that is why it might be more appealing for some other subsystems.
We have a viewer on YouTube who asks, what type of materials are there on Psyche? I'm guessing they're asking about the metals that we think that we'll find.
Scientists currently believe that it's mostly composed of nickel, iron core, and various other metals, which we will find out once we get to the asteroid.
And another person who maybe joined, since we answered this question a little bit earlier, but Janet on Facebook asks, will Psyche land on the asteroid or just orbit it?
No, we will just orbit it. We're not landing on the asteroid just because a lot of the characteristics of the asteroid are unknown, so it's probably a risk to land on the asteroid. I know a lot of people are picturing Armageddon, but this is not quite the case.
Yeah, and there are other missions, right, that have landed on asteroids and are bringing back samples. Just very soon, we have the OSIRIS-REx mission that's going to be bringing back samples from the asteroid Bennu. So all kinds of cool asteroid stuff happening with NASA this fall.
Definitely. Yep.
All right, let's see. We have so many good questions coming in, and we have a little bit more time. So if you are watching online and you have some more questions, please go ahead and continue dropping those in the chat. Our teams are monitoring those chats and getting them over to us. And we're getting some really, really great questions here. So Drew on X asks, what kind of science will the instruments on Psyche perform? What specifically do we hope to learn?
So the main science goal of this mission is to characterize Psyche. So we have numerous instruments. One will characterize the topography of Psyche. The other will characterize the elemental composition. And another will actually measure the magnetic field that may exist around Psyche.
Right. And for those who might have missed the very beginning, you were saying that scientists are thinking that this could be the metal-rich interior of a planetesimal, right? Something that is a metal core of all of the rocky planets that are in our inner solar system. But maybe there were a series of collisions that knocked off that rocky outer shell, correct?
Correct. So this mission is to confirm if it is in fact a metal core and what could have possibly happened to this young planet that is Psyche.
Right, because we're never going to be able to drill down to the core of our planet, unfortunately.
Exactly.
We have another question coming in on YouTube from Totaling Arc, who asks, will the craft protect itself against other debris?
So yes, all spacecrafts have a defense system in the form of panels so if you look at the Psyche spacecraft, it's almost like a box-like feature, and the panels that encase all of the interior of the spacecraft are structurally built so that it can withstand some debris. And we do perform what we call just kind of debris space environmental debris analysis to make sure that all of the structures on the spacecraft are robust enough to withstand small impacts.
Yeah, very important after you put all that hard work into it to keep the spacecraft safe. So yes, launch is right around the corner. October 5th is the opening of the launch period. And so Events and Entertainment on YouTube asks, after launch, how long until we start getting data?
Well, it will take about 6 years until we get to Psyche. So 6 years until we receive data concerning the asteroid itself. But we should be receiving data of the Psyche spacecraft's trajectory and its position, and possibly some images of the pathway that it's taking in space.
Yeah, it's important for people to remember that this is a 2.2 billion mile journey, right? So it's going to take a little while to get there.
A very long journey.
Yeah, beyond Mars, but before Jupiter, right?
Yes.
Kunal on YouTube asks, what is the data transfer technology used in Psyche to transfer the data to Earth?
Well, the Psyche spacecraft is using a new technology with an instrument called the DSOC. And this is an evolutionary, industry-breaking new technology that should bring back data at a much faster pace. I believe some of the other team members on the payload team would be better suited to answer this question. But from what I know, it's a brand new technology that is much more efficient in data mining.
Yes, DSOC's a great thing to talk about. And I believe that DSOC isn't actually going to be transmitting Psyche data, just from what I remember, but it is a groundbreaking technology that will be tested in deep space to really use to get our data back faster. So really great. And like I said, with one of the questions earlier, obviously, Julie, you're so knowledgeable about propulsion. There's not everything that you can remember about every piece of this mission.
Yeah.
So if people want to know more, check out nasa.gov/Psyche for all of the information. There's really great, just tons of information there. So let's go on to a couple more questions. Bill on X asks, what was the most challenging part of Psyche's development?
Well, the most challenging part is having to design and build Psyche's propulsion system, from my perspective, to withstand the thermal constraints of the deep space environment. It's a lot different than the thermal constraints of Earth. There's sun exposure, there's cold cases in vacuum. So it's a much more difficult requirement to build to, as well as making sure that our hardware is able to withstand any possible instances that can occur during that long 6-year mission to the asteroid. That's an extremely long journey, and there's a lot of unknowns in the 2.2 billion miles out there. So,
yeah, and that actually relates really well to Roger's question from YouTube. Why Psyche? Aren't there closer asteroids that could be visited?
Right. So most of the asteroids that are currently in space right now are made of rock and ice. The Psyche asteroid is unique in that we believe it is made of nickel iron, so mostly metallic. And again, this suggests that Psyche was the beginning of a planetary formation.
And everybody on Facebook's asking, Julie, where did you get your cool Psyche shirt?
Oh, well, this is our Maxar Psyche shirt, yep, it's pretty awesome.
Is it the spacecraft on it? I can't really see super close.
So it's the spacecraft with the asteroid.
Love it.
Yeah.
People always notice those things, which is so fun. And it's kind of interesting to note that the illustration that we have of the asteroid, like the one that's on your T-shirt, it's just an idea, right? It's not an actual. We don't know that that's exactly what the asteroid looks like.
Yep, it's what the scientists could compose and gather from what is currently existing out there in terms of data. And again, that's mostly radar observations and thermal inertia. So
cool. From one Julie to another, we have Julia on Facebook who's asking, how close will the spacecraft come to the Psyche asteroid?
So at the closest orbit, we will be about 75 kilometers above the surface, I believe.
Yeah, so pretty close.
Yep, very close.
Yeah. And for context, I heard a reference that the asteroid is roughly the size of Massachusetts, right?
Yes,
I think
that is
that's
correct.
a good visual context. Okay, so another really interesting kind of theoretical question here, Events and Entertainment on YouTube asks, will there be opportunities to image other astronauts, or not other astronauts, other asteroids on the way?
Possibly. I'm not certain if there are plans to take other images, but that could be a question for Dr. Lindy, who's our principal investigator.
Great. Brill Bond on YouTube wants to know if we can get a short movie on the Psyche mission. And I'll tell you, Brill, that we have lots of great video content. But Julie, what do you think about a Psyche documentary? Should we look into that?
Oh, definitely. I think that would be fantastic.
We have a couple of questions that are a little bit similar to ones you've answered before, but I'll ask just in case there's a different take that you want to share here. Daryl on Facebook asks, why is it important to study Psyche?
Well, to study Psyche would be to study the beginning of planetary formations. We are unable to study, obviously, our own planetary formation of Earth, and we are unable to see the core of Earth. So Psyche the Psyche asteroid would be the next best option. It's the only metal asteroid that we've detected so far that is within our capabilities to reach. So it will give us a better understanding of the planetary formations and how Earth came to be as well.
We answered one question earlier about the challenges of Psyche's development, but one thing I know that you talked about in your video was the benefit of working with people from different backgrounds. Can you talk a little bit about the team that's been working on Psyche?
Oh, yes. Well, I worked specifically extensively with my own internal propulsion team and JPL's propulsion team. Let me just say the most brilliant engineers I've ever worked with, both from Maxar and Propulsion. I'm only a tiny fraction of the hundreds of people that made Psyche possible, and particularly in Propulsion, I believe I'm one of dozens of propulsion engineers that work together to make this possible. From my own team, I contributed only a fraction. There were other key engineers such as Ian Johnson, Taylor Curl, and Ashton Murphy, who did a tremendous job. And the JPL engineers were amazing and fantastic as well, who, many of which that I've read their papers on, in school, and one of which was my UCLA professor. So that was great. It was, in a sense, like everything came full circle on this mission, and just learning from different disciplines, even not even in my own propulsion subsystem, but from the electrical systems team, from the mechanical team. I really appreciated and admired the teamwork and the collaboration that everyone had in attacking such a difficult and ambitious mission.
I love that answer. Thank you. One more, I think we're getting close to time here. Rachel on X asks, why did you choose to do this mission? Was it personal to you at all?
Well, I've always loved any mission that involves NASA science studies, because I think the science studies tests our limits, and it really pushes us beyond our boundaries. And it helps us understand a world that's beyond our own, and makes us appreciate, just the world that we live in. I definitely was very excited to participate in this mission because it is more challenging. Any mission that goes into deep space has a lot more challenges than missions that are that don't go as far into deep space, I should say.
Yeah, and that actually, I had one last question for you, and it connects really well to that because you talked about climbing mountains and skydiving, dreaming of being an astronaut, and now you're building spacecraft like Psyche. So what advice do you have for others who are fascinated by exploring and experiencing the unknown?
Yep. So I would definitely say just be fearless, test your limits, and explore to enrich your own understanding and widen your perspective of the world or the galaxy, and just never stop learning. You should never be comfortable in your life because I feel like if you are comfortable, that means you've stopped learning. So you should always be challenging yourselves and just have grit, perseverance, and resilience with anything that you do. Give it your all and dare mighty things.
Incredible answer. Well, unfortunately, that's all the time we have for questions today. Julie, thank you so much again for joining us today.
Thank you, Emily, and thank you for everyone who's called in or watched on all the social media platforms.
Yes, thanks to all of you for watching from home. To stay updated on the Psyche mission and its October 5th launch, follow NASA JPL and NASA Solar System on Facebook, X, and Instagram. And to learn more about this unique mission to a metal-rich asteroid, visit nasa.gov/Psyche. Thanks again for joining us as we continue to dare mighty things.